Good morning, guys. Today I am with the PS4 Slim, and its fault is that there is no power. When I press this button, there shows no indication of powering it on or the power light. There is nothing on the TV as well. So let's check for its fault. And here you can see that it is a sealed machine. To remove the power supply, we must remove these screws. And hopefully now we can take the power supply out. Yeah, it is. And disconnect this jack from the power supply. And here I will get a good power supply. Here is another power supply. It is good one. We can check with this. And here I place, and here I can fix it like this. And the power. Now we can, and here we can check it back that either the system is turning on or not. So that I am connecting the HDMI cable to. And here I will turn it on with the help of, yeah, it is on. So the power supply was bad. And here we can go to the display. If we can see the display, and yes, it's mean the only issue was with the power brick, the PSU, this one. And I will try to fix this power supply. Here I need to check the fuse with the help of this old meter. It is my old companion. So here you can see if I take it out. Here is its main power input socket, and one wire goes to this coil, and the other wire also goes to this coil, and these two wires are going to this bridge rectifier. So first of all we need to check for the fuse. It is continuity, and it is here too. So the fuse is fine, as you can check it like this. So now here are the points that are connected with this and this. Yes, the other point is this one. We can check it. So that all the circuit here is fine. So what's wrong with this power supply? These are the bridge circuit. This is the all four. These are the four diodes that are making a bridge circuit for converting AC to DC. These all are also fine. The bridge has 4 points, 1, 2, 3 and 4. These 2 points are for the AC input and these 2 points are for the positive and negative of DC. So I have checked that this portion is fine, and now the power supply is going to this rectifier, and this is the input of this rectifier, and it is from here. Yes, as you can see that this is the positive point, and it is going directly to this diode, and the diode is fine. So now this circuit is also fine, and here is a fuse, it's also good. It is also a second fuse, it is also good, and this resistor is fine. And now we must check for the standby volts power section. This section is for the standby volts power section because this is a standby jack here, and and this chopper transformer is generating 3.5 volts or 5 volts for this standby volt. So there must be a problem with this circuit because it is not giving even the standby volts. For this section I need to install some more things on this board to check it. Number one is this on off switch. I have made it to fix it here, and then it is a switch from a PS2 power supply or PS2 console, and I can insert the main line in this. First I have to turn it off, and I can give the main power, and here I need a load. This is a bulb. It is a normal motorcycle bulb, and I use it for the load. Here I should connect it, and I can do it like this. Yes. And one more thing that I should connect with this is a switch. Here is a switch. It is also from the PS2, and I have a series resistor of 1 kilo ohm for the protection. If it is not here, no problem. Just we need turn it on and off, and these connections will be on the 5 volt, and here it is. First pin is standby volts, and second pin is ground, third pin is AC/DC standby, and the fourth pin is AC in detection. So we must check it. Here I will turn it on, and here it is already on, but the bulb is off. It means it is not working. So to test it, I will set my meter on maybe 5 volt, 10 volts. It's okay. So first of all, we need to check that either the standby volts are present or not. They should be in order. This here is the ground. This point is ground, and here I will check the 5 volts. Yes, it is. And now the AC in detection volt, these also should be at 5 volt, and no, there is no volt. It is on, but no volts. It means that's the problem. Yes, and the standby volts are available. So guys, the important things to understand are these, that whenever we put main line in its socket, this portion is live as long as this cable is connected with the main, and on the other hand, this portion is also live because after connecting this main line and converting AC into the DC with the help of this bridge and this bridge, the voltages goes to this section to make the standby volts, the 5 volts that we require on these points, especially the first point that is called 5 volt standby. So whenever we press the PS power start button, this 5 volt goes to the AC DC standby pin. It connects with AC DC standby pin. Then these 12 volts where I have put this load bulb gets alive. So the main thing now to understand is that I have checked that the 5 volt standby are available. It means that this section that is making AC into the DC, it is converting AC into the DC, and on the other hand there is another bridge circuit that is converting AC into DC, and these voltages are going to this section. And here is a FET that drives this small chopper transformer to make the 5 volts for the standby. So one more thing, Sony has given a protection that to detect the AC voltage, either the AC voltage are connected, and these voltages must be on this pin number 4, AC in detection. So whenever we turn it on, now this section is on. I will put my voltmeter at DC volts, and here I will check for the volts on the standby pin number 1. There must be 5 volts, and they are. And this pin is just not having 5 volts, but when I will put this button at on position, and here I will get the 5 volts. It means these 5 volts are going through this switch to this pin. Here it should give the 12 volt. Now the 12 volt should be alive here, but there is no volt because this power supply is not in order. But the section, this section and this section and this FET are working because the chopper, this chopper is giving the outputs for the 5 volts for the standby. So as you have seen that the 5 volts are available here, and here I will let you check the volts. On this section the negative ground is this point. I have to be conscious because it contains very high voltage. So this is the ground, and this chip, the chip that is driving this FET, it has 7 pins, 4 pins here and 3 pins at this side, and you can get its diagram on the net. The first pin is latch pin. The latch pin that taking a signal from this chip, and the second pin is feedback pin, FB pin, and it is also getting a feedback from this coupler. Latch pin is getting signal from this coupler and the feedback getting from this coupler. And what is the use of this coupler? You can search on the net, because basically it is isolating the high voltage section from the low voltage section. These coupling are doing the same. And here is the third pin, this one. This is ampere sensor or sense pin. It senses that either there would not be any kind of overload. Whenever the power supply is due to any short circuit will be overload, these voltage will drop and this chip stops its oscillation for switching this FET, and the standby volts would not available. So here you can see pin number 3 is also not live, and the fourth pin is ground. It is really ground, as you can check it here. It is ground with this ground, yes. And the fifth pin is drive. The drive pin is driving this FET. This, it's mean this fifth pin, pin number 5, is giving a output of oscillation to switch this FET, and this oscillation is going on the gate of this FET. And here I will must check for the gate signal. There must be some volts. This one is ground, and here I will connect at the pin number 5, but there is no activity. Now let's come to pin number 6. Pin number 6 is the VCC pin. We will check it here. Yes, volts are there. Pin number 6. It should not be get short. I should be more precise on connecting this pin. Yeah, VCC volts are available, and they are about 15 volts. Okay, and the last pin, that is pin number 8 is high voltage pin. It is getting high voltage. It's mean high voltage mean the 220 volts from these diodes, and it is semi DC because no capacitor is involved in this line. It means it is a semi DC volts that are coming to the pin number 8. We can check it here. Pin number 8, yeah. I will set the meter on 250 volts range, and now I will try to check the volts, how much volt we are getting. Yeah, these are about 200 volts. It means 200 volts are available here. Now the next thing is that it means whenever we are getting VCC and other voltage, high voltage, it is switching this FET, and we can check the gate of this power supply for the switching. I think it is on. Yes, it is on, and this button is also on, and this is the output that is driving this gate FET. But at low range, should I check it at low range? And here, no activity. Okay, now as you have seen that the 5 volt DC is available here, it means it is working, and the 5 volts, we need the 5 volt for AC detection pin number 4, at pin number 4, and pin number 4 is connected with this resistor, and this resistor is getting volts from the pin number 2 of this chip. There should be 5 volts, and but we cannot get the 5 volts right now. As you can see that I connect here, and this is the pin number. It is not pin number 2, but it is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 number pin. The 10 number pin should give the 5 volts, and through this resistor these voltages will be available on this AC detection pin, and we are not getting any kind of volt. So now should I check for the oscillation on this chopper? The chopper coil is getting 220 volts from these diodes on this point. These two points are the primary coil of this chopper, and these 2 points are the secondary coil for this chopper. On the secondary coil we must get the 5 volts, and these 5 volts are rectified through this diode and this diode, and after rectifying these voltages, we more filter the volts through this capacitor. This is the capacitor. I think it should be a 100 microfarad and 35 volts, and here is another capacitor. This is also maybe 10 microfarad and 35 volt. So we must get the volts on this capacitor positive or at the cathode of this diode. So let's check it. Can we get volts here? But the volts are dropping, not stable, and they should be 5 volts. But at the moment I am detecting that it is giving only 1 volt and also drops down after 2 volts. So I have to check it on my oscilloscope, the shape of the signal on the gate of this FET and the output here on the diode. So for this, now it is very dangerous to check it here with my oscilloscope because I need to handle this metal probe and but we must do it. And my oscilloscope is now on analog mode, and here is the ground. Ground is connected, and you can see on this oscilloscope. Now I'm going to check the volts input on this. There is a sort of oscillated voltages, and at the output point the volts are there but they are not filtered. Yes, it's mean this signal is in sine wave shape. If I can show you clearly, here is somehow sine wave. It is not. It's mean it is not filtered by this capacitor. This capacitor is this one is the ground, and this is the positive point of the capacitor. And here I should also check this capacitor. This is high voltage, and this is the ground. And for high voltage, I have to reduce the volt division, and then I can check its shape. Yeah, it is also not filtered. As you can see, it looks like a sweep voltage. That is not good. So first of all, I need to check for this capacitor. So I will turn it off and off, and here I also need to discharge this capacitor because there are high voltage very high voltage at about 390 volts in this capacitor. So I need to pull out there is a one capacitor is 6.8 microfarad and 50 volts, and this one is 100 microfarad and 35 volts. So first of all, I will pull out this capacitor. It looks fine, but okay. I have got this other capacitor. This one is 100 microfarad, 35 volts. And I will try to, and here I will try to solve it. think it looks fine. The connections I have made are fine. Now let's check for the shape of these voltages. These are the 5 voltages that are less than 5, so I have to turn it on. Yes, and here I will turn it on to this. Oh yes, oh yes, my load is grown up now. As you can see that it is working, but we must see the voltages at the diode. Are they smooth or not? Oh yes, now there is no sine wave, but it is smooth. And here I will put, there must be 5 volts, and 5 volts are, there should, this line should be at 1 2 3 4 5 here. But they are more than 5 volts. Okay, let's check with the help of this analog meter. Here are the 10 volt range, and I will check the volts here. More than 5 volts. But now we need to check that the AC in detection pin got the volts or not. So here is the ground of this circuit is this. This is the ground pin, and here now I will check for the volt. Yes, now I have got 4.3 volts. These are the volts that we require to switch on this power supply, because these voltages are getting, this pin is getting these voltages from this pin number 2. I will let you check that either this pin number 2 is getting the same voltage. Here, this is the ground. The bulb aside because it is burning my eyes. This is the ground, and here I will connect, and yes, the same voltage, and the coupling resistor is this one, and on the other point we must get the same volt, 4.3 volts. Yes, and the same volt here, 4.3 volt at AC detection pin. So everything is now smooth. The sine wave voltages has been converted into the smooth DC volts, and these DC volts are, now what is happening here? I will turn it off. Now these voltages that we have smoothened here, and these voltages were the output of this secondary coil. This is the primary coil on which we are giving the high voltages, and through this FET it is operating, and when it gets operated, then we can get 4.5 volts or 5 volts from its secondary coil, and these, and after getting these 5 volts we need these voltages on this coupler to tell this chip that the 5 volts are available, and through this coupler these voltages are sensed by this chip, and then and the voltages are sensed on the pin number. It was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and pin number 11. The pin number 11 is the input for the 4.5 volts, and the pin number 10 is the output of this chip for the AC detection volts. So I let you check. Here you can see on this multimeter that this pin number 3 is switched by, I need to set it on continuity mode, and this pin number 3 is getting volts. I think these voltages are from one of this coupler. Yes, this coupler is giving volt to this pin number 8, 9, 11, and then we get the output of 4.3 volt from pin number 10 for this pin. This pin is connected with this pin number 2 via this resistor, and here you can see. So this is a very complicated circuitry the Sony has made, but we should know about this circuit, and for understanding this circuit, first of all you must be familiar with the electronics